So here we are looking at complex zeros. This topic won't be that much different than looking at the real zeros, but now we're going to look for every single zero and we're going to include the complex numbers that include an imaginary portion. So for this problem, find all the zeros and write in factored form. Really it follows the same steps as what we did in the last section. And so we're going to start by finding all the possible rational zeros. So as you can see, since it's degree 4, right, we could have 4 total zeros and we would have up to 4 real zeros. Okay, so up to 4 real zeros, and some may be complex zeros, and that's kind of what we're talking about in this section. So up to 4 real zeros, and we want to look for 4 total zeros. Okay, and remember that the first step that we have been doing is listing all the possible rational zeros. I know there's a lot of, there's real zeros, complex zeros, rational zeros. So try to remember what rational means. Okay, rational means it could be a whole number or it's a number that can be written as a fraction. Okay, so those are those better numbers you want to think about. They don't have the square root of 3 in them. They could be a fraction, could be like a, if it was 0.3 repeating, like 0.3333, that would be 1/3 because that can be written as a fraction. Okay, or they could just be any positive or negative whole number. So the possible rational zeros, remember that is the plus or minus p over q, right? So in this case, p is negative 18. So, we really just listed all the p's, sorry. The p is the factors of negative 18 is how I probably should say that. So negative 18 is that constant term. So we want plus or minus 1, 2, 3, 4 doesn't go into 18, 5, 6, 9, and 18, right? So those are all the factors of 18. Q is the factors of the leading coefficient. In this case, that's 3. So that's plus or minus 1 and plus or minus 3. So our possible rationals are the p's divided by the q's. So first, it's all the whole numbers. Okay, and then we have to put all of these p's divided by the 3 as well. So that adds plus or minus 1/3, plus or minus 2/3, 3/3 no, 6/3, 9/3, 18/3 no more. Okay, so just adding in plus or minus 1/3 and plus or minus 2/3. All right, second, we look at the graph and find all rational zeros. Find all rational zeros. And of course, that's a calculator graph. You're not trying to graph these really without a calculator. All right, so graph this for you. Here is the equation, right? And then this is what the graph looks like. I did zoom out a little bit so you could see the bottom of the graph. It does have a minimum there. It should not look exactly like a parabola. If you notice, it's a little off center, and that's because it's a 4th degree function, okay? But what you can see from this graph is there are 2 real zeros, and we'll find what those are. And then there are 2 imaginary zeros because they are not showing up on the x-axis, okay? And that's what makes this graph have this kind of off-center curve. All right, so to save us time, I already found the 2 zeros. This one's pretty clearly -2, and this one happens to be 1/3. Remember, it has to be in this list. If it is rational, it's going to be in this p over q list. So I found those for us. So the 2 from the graph are x is equal to -2 and positive 1/3. Okay, so these are the real rational zeros. Okay, looking at our function, since we have 4 total, that means that there are 2 complex zeros, and that's our task now is to find those as well. So we're not going to find those from a calculator. We have to find those by hand. Okay, the method is the same though as in the last section. So the third step was to divide, right? We're going to use synthetic division. We're going to divide out both of these zeros. Okay, so our first zero we can put on the shelf -2, and then list out all the coefficients and do your synthetic division. Okay, so we're going to multiply and add across. Okay, recall to yourself why you should be happy that you get that remainder of 0, right? Okay, now remember, if we have two real or rational zeros that we want to divide out, we don't write the function now. We just keep dividing. So now we're putting positive 1/3 on the shelf, and we are continuing. We got 0 again, of course, okay? And now recall, when you divide with a fraction on the shelf, we need to divide again, dividing by the denominator, okay, that 3. So this and this and this are all divided by 3. So this is just a 1, a 0, and then a 9. And so in other words, our function is x squared plus 9. Okay, there's no x term. This is the constant term, remainder constant term, x squared term. Okay, so x squared plus 9. So now we are on to step 4. And step 4 was take that remaining, hopefully quadratic, but take that remaining function, set it equal to 0, and see how you can find the other zeros. Okay, so what happens here, x squared, we can just subtract 9. Okay, then to solve for x, we take the square root of both sides, right? So we get x is equal to, and now we have this, we have plus or minus the square root of -9, right? This is that non-real answer. We were always told when we first learned square roots, like you can't take the square root of a negative number because like what number squared would equal a negative number, right? Think about 3. 3 squared is equal to 9, but -3 squared, so -3 times -3 is also equal to 9. So there's not a way to square a real number and get a negative number. That's why once you got to high school or upper math, then you have to learn about the imaginary numbers, where they said, well, really you can take the square root of a negative number. It just doesn't show up on the graph, just a regular XY graph, okay? So how we determine that, or how we look at it, is that negative we're going to call the imaginary unit. Okay, so the square root of 9, so this is equal to plus or minus the square root of -1 times the square root of 9, right? Because the square root of 9 is 3. And now we're going to call this square root of -1, I, imaginary unit. So this is plus or minus 3i. Okay, and so we're going to put a little definition up here. My favorite kind of definition, no words, just math. The I is equal to the square root of -1. Okay, it's like it can't exist until you define it. So now that we've said, hey, the square root of -1, it's just always going to be I. Okay, so now these are the other two real zeros, or zeros, not real zeros, but zeros. So let's list the zeros, so our answer, right? So the zeros for this function are x equals, and then we had -2 and positive a third, and then we have 3i and negative 3i. Okay, and then we also asked for factored form. So f of x is equal to, remember, it's always going to be in parentheses, x minus the 0, x minus the 0. Okay, if you know that, then these get to be pretty easy. So this would be x minus negative 2. So that's x plus 2. Okay, this is x minus a third. We'll talk about writing that in a different way in a second. This is x minus 3i, and this is x plus 3i. All right, so let's just, to finish this problem, we're going to say that x minus a third, most of the time you're going to see this written, this 0 is the same as 3x minus 1, right? That gives the 0 1/3. And this 3, remember that our initial problem, what the leading coefficient was 3, and then it was x to the 4th. So you really want to write that one as 3x minus 1 when you are writing your final answer. So this is factored over the complex numbers. Okay, so this is f of x factored over the complex numbers. If you were factoring over the real numbers, you would stop right there at x squared plus 9, which is what we did in the last section, right? All right.